u-substitution, or you call it integration by substitution. The first integral, we have integral of 6x squared times e raised to negative x to the third. Do you see that this piece, the e raised to negative x to the third, this is an composition function, right? We have a negative x to the third inside an exponential function. Therefore, I am going to let u equals to negative x to the third power. All right, and then the du, the next step of the u substitution is you differentiate u with respect to x. So usually you write du over dx, right? That is equals to negative 3x squared. But do me a favor, don't put the dx on the left hand side, just multiply dx on both sides. So don't put it right there. Just multiply dx on both sides. So you have a negative 3x squared dx. And then the next step is isolate dx on the right hand side. So you have 1 divided by negative 3x squared du equals to dx. And then you do a change of variable. So you will replace the differential with this. All right, and then that becomes integral 6x squared e to the u, right? And then 1 divided by negative 3x squared du. Do you see that there are some cancellations? So the 6 and the negative 3, so that becomes a negative 2, right? And then the x squared cancels with the x squared, and then you have the e to the u du. Okay, since du is now the differential, make sure there are no more x. If there is still one x, and then you keep going, that means they are all wrong. Okay, and then what's the integral of e to the u? The integral of e to the anything is e to the anything, right? So this is a negative 2 e to the u plus c, and then you put the x back, so you have a negative 2 e to the negative x to the third plus c, and then this is done. Okay, moving on to the next problem. The next problem, we have an ln, right? So we have an integral 5 divided by x times ln x dx. So this one, there are no composition function. I will just let u equals to ln x. Because the derivative of ln is 1 over x, I can get rid of the x that is right next to ln. How come you don't let u equals to x? If you let u equals to x, this is the biggest mistake that people make in u substitution. If you let u equals to x, all you did is you change the variable from x to u. That's it. You haven't done anything. All you have to do is you change the name of the variable. You haven't done anything that helps you to integrate the function. So never let u equals to x. That is the biggest mistake that people make in u substitution. Erase that. Huge mistake. And then what's the derivative of ln? The derivative of ln is 1 over x, right? So du is equals to 1 over x dx, and then keep the dx on one side. So you have to multiply x on both sides. So you have x times du equals to dx, and then you do the change of variable. So you are going to replace this to this place. By the way, let me write this down. We have space. So if you just let u equals to x, so let u equals to x, this is a huge mistake. Huge mistake that people make in u substitution. If you start with this, if I see this on your paper, you get a 0. Okay, continue. And then we have integral 5 divided by x. The ln is now a u, so you have a x times du, and then cancellation, get rid of the x. So now u is the only variable, so that is 5 times integral 1 over u du. Then this is an ln, right? So this is a 5 ln absolute value of u plus c, and then this is the u is ln, so you have an ln inside another ln, so 5 ln, and then this is ln x, right? So this is wrapped by an absolute value plus c. Can you remove the absolute value? The answer is no, because ln can be positive, 0, or negative. So that's why keeping the absolute value is required. Okay, moving on to the red one. The red one, we have integral e to the x minus e to the negative 3x dx. This one, you can break this down into two integrals. The first one is integral e to the x dx, and then minus integral e to the negative 3x dx, and then the minus is carried over there. All right, so the integral of e to the x, this is just e to the x, right? And then how about e to the negative 3x? That you have to use a u substitution. I will let u equals to negative 3x, and then du is equals to negative 3 dx, and then 1 divided by negative 3 du equals to dx. And then we do a change of variable. So this is change of variable. And then we have, what do we have? We have e to the x, the minus is carry over. And then minus 1, minus integral 1 over, no, we should start with the e to the u, right? And then 1 over negative 3 du. Okay, nothing needs to be cancelled, and there are no more x. Okay, so we will have to integrate the e to the u. So this is a e to the x plus 1 over 3 integral e to the u du, which is just e to the u. So this is e to the x plus 1/3 e to the u, and then plus c, and then you put the u back, so you have e to the x plus 1/3 e to the negative 3x plus c, and then this is your final answer. And then how do I get a plus? Because this is a minus, and then this is a minus, so the two minuses becomes a plus. All right, and then the last one we have, what color did I use? I used purple. Okay, so we have integral a e to the 4x divided by 3 plus e to the 4x and then dx. So this one, if you let x equals to 4x, that doesn't do anything. You can try. So when you are doing your homework, you let u equals to 4x and then that doesn't do anything, it's okay. Don't be afraid of making such kind of mistake, because you are doing homework, you are practice. Making mistake is fine. So if that u is not going to work, then you have to pick something else. So I will just pick u equals to 3 plus e to the 4x, because the derivative is enough to get rid of the numerator. So du, the derivative of 3 is 0, the derivative of e to the 4x is e to the 4x, and you have to use a chain rule. The derivative of 4x is equals to 4, and then dx. So this 4 is came from a chain rule. All right, and then 1 divided by 4 e to the 4x du equals to dx, and then you perform the change of variable. So change the differential to this piece. All right, then we have a e to the 4x, the entire denominator is a u, and then 1 divided by 4 e to the 4x, and then du, and we can see a beautiful cancellation, e to the 4x, and then the a divided by 4 is equals to 2. So we have a 2, right? So we have a 2 integral 1 over u du. This is an ln, right? So this is a 2 ln absolute value of u plus c, and then the u is 3 plus 4 e to the 4x. So this is always positive. So 3 plus e to the 4x is always positive. E to the 4x itself is always positive. Positive, you add a 3 to it, is always positive. So therefore, we do not use the absolute value. So this is a 2 ln parenthesis 3 plus e to the 4x and then plus c. So this is your final answer. And then you might ask me, hey, what if I have 3 minus e to the 4x? So that is a big what if. So what if you have a 2 ln 3 minus e to the 4x. So e to the 4x, let's say x equals to 1, let's say, how about x equals to 10? 3 times 4 times 10, 40. E to the 40 is pretty big, right? So 3 minus that is absolutely negative. So therefore, if the sign is a minus, we can have a negative. So when we can have a negative, then we have to use an absolute value. Because 3 minus 4, e to the 4x can be negative. Whenever this can happen, you have to use an absolute value. And whether or not, should you use absolute value or not, it is your responsibility to figure this out. Okay, so that is the end of this video. If you like it, if you think that is helpful, give me a like, share, and subscribe. I appreciate your help, and I will catch you all in the next one. Signing off.